And so what that means is there is at least a 0.95 times 0.95, which is, what is that? I don't have a calculator. So 85.5 plus 4.75, and you get 5, 12. So you have at least a 90.25% chance, or probability of 0.9025. So you have at least a 90.25% chance that the two population means are different. So there's at least a 90.25% chance that the mean annual income of all American households is different than the mean annual income of all European households. And that finishes the chapter 20 and 21 problems. All right. So now we're going to move on, and all these calculations are in the notes. Now we're going to move on to the hypothesis tests. Now remember, that's going to include everything in the cheat sheet that goes from page 8 of the cheat sheet on. And just like in the video I gave on hypothesis tests, we're going to follow a flow chart for both hypothesis tests. The hypothesis test for problem 9 is a claim about a population percentage, so we're going to use in our cheat sheet the flow chart that says it's from page 545 to 546 from another book, which gives a 6-step process for determining, for testing a claim about a population percentage using sample statistics. So if we go to problem 9 on the practice test, it says, suppose a company claims that fewer than 2% of their manufactured products are seriously flawed. Now, remember, the first thing we got to do to set up a hypothesis test is to write the given claim down in symbolic language. We have to convert everything into proportions, so we have to write the claim that's given in English. The claim being that this company claims that fewer than 2% of their manufactured products are seriously flawed. It says we're seriously flawed is some kind of pre-prescribed criteria that they have. We have to write that in symbolic language. So we have to write it so that whatever the population proportion is, the claim is that is some inequality sign, that the population proportion for this category is either greater than or less than, or greater than or equal or less than or equal to some number, which we're going to call P0. And if you read the words, claims that fewer than 2% of their manufactured products, that's the same as saying what? The population proportion is less than. Fewer means less than. And how do you write 2% as a proportion? You write it as 0.02. So the symbolic language for the claim is that the population proportion is less than 0.02. That's what you mean when you say that fewer than 2% of the category is in the category, which is seriously flawed here. So the population proportion of all items that are seriously flawed is less than 0.02. So that's writing the claim in symbolic language as P inequality sign P0. All right, did that all come in? Okay, so the next thing you do after you get the claim translated into symbolic language as P inequality sign P naught, where P naught is some number between 0 and 1, you now want to also write the counterclaim, which is like the complementary claim, also in symbolic language. So you look at P less than 0.02 and you say, well, if the population proportion is not less than 0.02, what does that mean? The counterclaim is saying that the population proportion is not less than 0.02. So that's the same as saying what? The population proportion is greater than or equal to 0.02. And remember, only one of the claim or counterclaim can have an equal sign and its inequality sign. Right? And just like in all the problems from her book, the inequality sign that has the equal sign is always going to come from the counterclaim. That's what she claims to be the baseline claim. The counterclaim is always going to be the baseline that gets compared against the claim. So the claim should always involve either less than or greater than in this book. It doesn't have to in general, as I pointed out in the last video, but for all the examples in her book, the claim is either going to involve a less than or a greater than sign, and the counterclaim will always be a greater than or equal or a less than or equal sign. Now, remember, for step 1, we have to convert these into a null hypothesis and an alternative hypothesis. So if you look on page 546 of that flowchart that comes in your cheat sheet, we're doing page 545 of that. It's a handout that says page 545 at the top. We're doing the p-value method. The first thing you do is you write either the one that doesn't have the equal sign, and that's going to be the claim. That becomes the alternative hypothesis, and we write it as H1. So H1 is the claim that came from is the claim written in symbolic language. So here our H1, our alternative hypothesis, is P is less than 0.02. And that came from the claim. Which means that we get our null hypothesis, H0, from the counterclaim. That's the one that contains the equal sign. And when we write the null hypothesis, we don't write it as greater than or equal or less than or equal. We turn the inequality sign with the equal sign into an equal sign. So the null hypothesis is not actually equal to the counterclaim per se. It's just that we use the counterclaim to make the null hypothesis. We take the greater than or equal sign, since it has, and we rewrite it as H naught, null hypothesis, but we write it as P equals 0.02. So we have H1, the alternative hypothesis, is P is less than 0.02, and we have the null hypothesis, which comes from the counterclaim, to be P equals 0.02. And if you're having trouble reading this, just follow along. It's all given in the solution key. All this information has been given in the solution key, step by step, for the practice test for test 3. So, we have the claim and counterclaim written in terms of the alternative and null hypothesis. Notice that since the alternative hypothesis has a less than sign, that means this is a left-tailed test. If the alternative hypothesis had a greater than sign, or saying the claim had a greater than sign, it would be a right-tailed test. But since the claim, which became the alternative, had a less than sign, it's a left-tailed test. So that's the end of step 2. It's a left-tailed test. The alternative hypothesis is P less than 0.02. The null hypothesis, which comes from the counterclaim, is P equals 0.02. So that ends step 1. Now we move to step 2. So now when you go to page 545, go down to step 2. And step 2 says, select a significance level alpha depending on the seriousness of making a type 1 error. Now, in these problems, we're given a significance level in the problem. So if we read the rest of this problem, it says that we're testing the claim that fewer than 2% of the manufactured products of this company are seriously flawed, and we're using a significance level which is given to be alpha 0.05. So you don't have to determine the significance level in step 2. That significant level is part of the given information. It's always given in the problem, and in this case, the significance level that's given in this problem is 0.05. That's the same as saying confidence level is 95% for this test. Now, we have to give the sample statistics here before we can go on to step 3. For step 3, we need to calculate the test statistic, and we need to use all the given sample statistics. Now, what's given in the problem is we took a simple random sample of 900 finished products from this company that were taken directly off the assembly line and tested. So we didn't sample all the products. We didn't do a census. We only did an inferential study to test this claim, which means there will be a sample size. The sample size is 900, since we randomly selected 900 products from the assembly line and tested them. It was determined that out of those 900 products, 12 of those products turned out to be seriously flawed. So the relevant category here is seriously flawed, and X is the number of members of the sample that are in the category. So here our X is 12 because there were 12 items in the sample of 900 that tested as being seriously flawed. Now, once again, we use our little formula for the sample proportion. The sample proportion is always X over N. That gives the proportion of all products from the sample that were seriously flawed. And here that's 12 over 900. Is all this coming in? And if you use your calculator, what you come up with here is that 12 over 900 is approximately equal to 0.0133 rounded to 3 significant figures. So, using the given sample information, and of course from step 2 we have the significance level, but for step 3 we need the sample size, we need the number of elements from the number of members of the sample that are in the relevant category so that we can calculate p hat, and then from that, and using the sample size, we plug into the formula in step 3 that's given for the test statistic. And that formula in step 3 is given as a z-score, and it says z is equal to p hat minus p naught divided by the square root of, and you can put all this in your calculator if you enter it incorrectly. If you have a graphic, this all could be entered in correctly if you're careful, so that you could just press enter. So it's p hat minus p naught in the numerator, and then divided by the square root of p naught times 1 minus p naught, all divided by n. And that formula is in the flow chart. That formula is given for step 3 in the flow chart on page 545. It's kind of hard to see it here. I'm going to move this down a bit. Yeah. Okay. So I'm going to plug into that formula now. So I'm going to erase this so you can see it a little bit better. So what we have is z equals p hat minus p naught divided by the square root of p naught times 1 minus p naught over n. And what we found out was, remember, that p hat was equal to 0.0133, and our p naught came from the claim. The p naught was the 0.02. That's what you claim the population proportion is less than.